Let's talk about the decimal division algorithm and why it makes sense. But first, let's step back and look at why, if you were seeing this for the first time, it might be really surprising. When we learn multiplication, 1 2/10 times 3/10, typically we ignore the decimal point, do our multiplication as if we had whole numbers, and then we come back and we adjust. We had 2 places to the right of the decimal, so we need to have 2 places to the right of the decimal. So with multiplication, we have to adjust the decimal point at the end. Okay, so if you've just been working on decimal multiplication, you might think you have to do the same thing for decimal division, but it turns out that you don't. If I take 1 2/10 divided by 0.3, I can move the decimal 1 place to the right. This becomes 12 divided by 3, and the answer is 4, and I'm just done. In this case, I have no adjustment. No adjustment of the decimal point at the end. So let's think about why this is reasonable. If I have 1 2/10 divided by 3/10, I can rewrite this as a fraction. 1.2 in the numerator, 0.3 in the denominator. Then I could write this as an equivalent fraction, so I could multiply the numerator and the denominator both by 10, and that would give me 12 thirds, 12 divided by 3. So I know that these are equivalent fractions, and I know that these are equivalent division problems. Because they're equivalent, there's no need to adjust the decimal. Okay, let's approach this from another perspective. Let's use our base 10 blocks. We're going to make a key, and in this case, we're going to say that our rod is equal to 1, and then our flat, which is made of 10 rods, is equal to 10. So these 3 rods are equal to 3. The flat is 10, and over here, these are 2 rods, so this is 12. I can break my flat up into 10 rods. Then I have a total of 12 rods. And now I want to break up even further. I want to subdivide into groups of 3. So I'm going to be grouping 3 rods together. And I end up with a total of 4 groups of 3 rods for my 12 rods total. This is the problem. 12 divided by 3 equals 4. All right, let's change up our key now. Let's say that our key had the more traditional, a single is worth 1, a rod is worth 10, and a flat is worth 100. Then this becomes 3 rods are worth 30, and we have 120 over here on the right. I still have 12 rods. I still have 4 groups of 3 rods. It's still the same equivalent model. I've just labeled it differently. So here I have 120 divided by 30, and I have moved the decimal point 1 place to the left and made this 12 divided by 3 is 4. I have 4 groups of 30, or 4 groups of 3 rods. Let's do this again. Let's have the key, and this time let's have the rod be worth 1/10, then the flat is going to be worth 1. So we have 3/10, and we have 1 2/10. Still same model, different labels. We have our 12 rods, and we have our 4 groups of 3. So if I think of 1 2/10 divided by 3/10, moving the decimal one place to the right, this becomes the problem 12 divided by 3 is 4. These are equivalent problems. We get 4 groups of 3 rods or 4 groups of 3/10. One more time just to drive the point home. Let's have the rod be 1/100th, and then the flat will be 1/10. So we have 3/100ths, and we have 12/100ths over here. 12 rods, 4 groups of 3. Here's our division problem. I can move my decimal point 1 2 places to the right, and I end up with 12 divided by 3, and this is 4. Again, if we look at our fractions, if we have 12/100ths divided by 3/100ths, we can write this as a fraction. We can multiply the numerator and the denominator both by 100 to get the equivalent fraction of 12/3, which is the same division problem. Okay, let's put this in action. In summary, if we have a division problem, we can make the divisor a whole number by moving the decimal point in either direction as many places as we need, and then we can adjust the decimal point of the dividend in the exact same way, and there's no need to compensate at the end. We just proceed with regular long division. So here we go. This problem, 65 428 thousandths divided by 4/100ths. Well, my divisor, I'm going to move the decimal point 2 places to the right, 2 places to the right. This becomes the problem 6,542.8 divided by 4. So I know how to do long division when there's a decimal point in the dividend, and then as long as I make the divisor a whole number, I can proceed as normal. So the answer to my problem is 1,635 7/10.